Hey everyone, it's Patrick from the Babylon.js team. Welcome back to the channel. Today I want to talk about part 2 of our series on PBR nodes in the node material, and we're going to make something that looks a little bit like this. So what we have here is a very simple scene. It has 4 meshes in it, 3 dice and a ground plane. The ground plane is using a custom shader that is catching shadows, but it is unlit as well, so there is no lighting contribution onto the ground. And what we're going to be creating in today's video is this die here. So we're going to have a dielectric material, a plastic material that has kind of this really interesting iridescent quality because we're picking up sheen of this pink color on glancing angles in the faces. We're also going to create the paint inside the numbers. So it's going to look different than the plastic material because the paint should have a different roughness and color than the plastic material. So it's a very simple, very straightforward process. But we're going to dive into both how to create the unlit shadow catcher for the ground and the material on the die here. Now, the other 2 dice you see here in the scene are the way that they import by default from the GLTF. In the GLTF, I created a standard PBR material that has just a normal map, and then I pumped this mask for the numbers into the red channel of a packed texture that normally we would use for what we call an ORM texture, or an ambient occlusion roughness metallic texture. And we put each of those maps in the R, G, and B channels, respectively. In this case, I don't care about the ORM pack. I don't really care about the metallic and roughness channels, but I did set them just so that when we import the mesh, it would look correct. They are non-metallic and semi-rough. But the red channel, I put the mask that we're going to use to isolate the numbers in. So the reason I did that is when I import the GLTF file by itself, I have access to the textures that it brings along. And so I don't have to load the mask texture in or the normal texture in separately from the others. So that's why these 2 look black and white, and we're going to dive into those in future videos. So let me jump over to this scene here. And what I've done is we're going to be working on this left die here, and I've set up the base material with the PBR nodes the way we had talked about in the last video. So we'll link the video below so you can make sure you see it. I didn't want to spend a lot of time wiring up the basics, so I did that for us already. So what I'm going to do is let me set up the scene here so that we can walk through it. And actually, before we jump into the node material, let me walk you through what the code is doing, just so that we can touch on all of the things you might need to know for the scene itself. And then we'll dive into the ground plane shader, and then we'll create the shader for the die. So the scene is very simple. We set up our scene using our camera up here. We set up some environment light, and you can see this is right now just a white material, but the environment that we're using is kind of a sunset exterior environment. So that's why we're getting a lot of the pinks and the oranges in the reflection of the white dye. And the direction of the sun is coming from this direction, so it matches up with the shadows that are cast on the ground, so that it all feels like it fits together. Then we have our directional light. Now, directional light is what we use to create this contact hardening shadow. And there's an important thing to note on our directional light is that we have to set up a shadow min Z and a shadow max Z. And you can see in our scene, we have 0.4 to 1 as the range between min and max. And the reason it's so small is because the smaller you get the range between the min and max, the more precision you have on your shadows. Now, our scene is very small because these are, real size dice, and so the scene itself is a very small scene. So I can get away with a very, very small range. But even in a larger scene, you still want to keep the range between min and max Z as short as you can, so that you can continue a high precision in your shadows. They will look better that way. The next thing we do is load in our meshes. Now, I mentioned before that I created these meshes with a PBR material in them that load the normal map and the mask as well. And so when I bring those in, I grab all of the meshes that we need because we need to know the 3 dice individually and we need to know the ground plane. So I grab those and assign those to some parameters. Then we grab the textures from those and assign those to variables in the scene as well, so that we have the textures that we can assign to our shader. In the next part here, we create our node materials and grab the texture nodes in the node materials and then assign our textures to them. So we can make use of the fact that the texture is loaded with the GLTF file itself, and we didn't have to load those manually. And then this last part here is just setting up the shadow generator. This part is very simple. We create a shadow generator. We set our use contact hardening shadows to true. We set up the UV size ratio, which shows you how much of a penumbra blend you're going to get on the shadows. And then the darkness is how dark are the shadows in the scene. And then we just add our shadow casters to the 3 dice meshes and set our ground plane to receive shadows. So it's very, very simple. But let me dive into the ground plane shader just so that we can see how that's created. It is a very, very simple shader. And the reason being is because I wanted the environment to be kind of this blank void and not be able to see any difference between the ground and the clear color of the scene, I wanted to make sure that we don't have any light contribution to the ground plane. So the way I did that is, again, let me pop this back open again. It is a very, very simple shader, very simple technique. And because I have to have shadows on the ground plane, I have to bring in a node that will give me a shadow output. Now, the one I chose here is the lights node. And the reason I chose the lights node is it is just a simple blend Phong light model. And we're using PBR on the rest of the scene, but I did not need PBR here because if you look at what I'm doing, I'm just taking a ground color and then scaling it by the shadow in the scene and then pushing that to the fragment out. So I don't have any light information hitting the ground plane at all. It makes it an unlit material. If I brought in the PBR node, which I certainly can because it does have a shadow out, it is just a much heavier node. There's a lot more computation that goes on. There's a lot more setup that needs to happen with it. And so there's absolutely no reason to bring that in if the only thing I care about are the shadows. And so here I wire up the bare minimum of what we need, which is just world position, world normal, and camera position. And then I can output the shadow contribution, which is then scaling our ground color. And that's how we're getting our shadows in the scene. Very simple technique. And then the color that I chose, that color 3, if I come in here and turn on the bounding box of our ground plane, you can see there is the bounding box on the ground plane. And let me move this over so we can see the scene a little bit more. Anything outside of that ground plane is just the scene clear color. And I just use the same color over again that was set in the ground node material. So when I don't have that on, you can't see the edge of the ground or where it overlaps with the scene color, so the clear color in the scene. So it does feel like this empty void. It's a very, very simple technique. I like it. So now let's jump in and build the material for the dice. So I have this loaded up here, and let me actually rotate this around so I can see the die while we're working on it, and zoom in just a little bit, and then open this up and we'll set up our scene again. Okay, so here, what we're doing is, this is kind of the things that I talked about in the last video, and I just quickly wired them up just to save time so that we didn't have to go through each of those steps again. Very simple shader setup so far. We have our vertex output at the top. We have our world position, world normal, world tangent matrices here in the left here. We have our PBR metallic roughness with the bare minimum that we need to wire it up and have it compile. And that we're taking the lighting straight out to the fragment out. And so you'll also see that I have 2 texture nodes. One is for the normal texture, and the other is for that mask texture that I talked about, where we have the mask of the numbers in the red channel for that texture. And the easiest way for me to show that is just to, let's wire this up, and then you can see that texture right on the die itself. So white numbers and a black background. So when we apply that mask, anything that is black will not be affected, and anything that is white will be affected. And that will come in handy when we're setting up our base color and our roughness. So let me wire back our lighting. And let's go through these quickly. We've got a world position wired up, normal position, or world normal wired up, our view matrix, camera position, our perturb normal. This is the one that if you need a normal map, you will have to set this up. And we talked about it in the last video, but I didn't wire it up completely. So this is a full wire of the perturb normal block. So the perturb normal block takes a world position, world normal, world tangent. It takes UVs, so from our mesh UV. And then our normal map color is what we are going to use typically as a texture node. So I import a texture node. And when I select this, you remember last time we talked about all of these inputs are expecting a linear input. I did not have, on this one, you can see I don't have either convert to linear or convert to gamma checked. And the reason that is when you bake out your normal map, and I baked this one out from Substance Painter, it's going to bake out the raw values in linear space. So when it saves it to a ping, even though a ping technically is considered by default gamma space, the software will write out linear space values in the ping. So even though I bring it in and it's a ping file, I know for a fact those are linear values in the texture itself. So I don't want to do any kind of conversion, because if I do a conversion, the values are going to be wrong, which means our vectors are going to be wrong on our normal map, and that's going to make the lighting look incorrect. So you can see here I did not set these, but that's only because I know for a fact that the values in the texture are already in linear space, and so I don't have to do that conversion. Here, our base color should be in linear space, so I would check that to make sure that we're passing it through. Because it's white, there isn't a difference that you'll see. So if you're using white or black, linear or gamma space will be the same value. So you do want to make sure you check that for certain when you're wiring up color 3 nodes into the PBR metallic node, because we know that we need linear values there. And our metallic and roughness are just floats. And you'll notice for any of you eagle-eyed viewers who saw the last one, we do have a little bit of a change here in our float nodes. And you'll see that we used to have 2 decimal places worth of precision, and now we have 4. So that was a change that went in very recently. Thanks to Pamela on our team for adding that in. That extra precision is really awesome. And so then we'll jump down here and we see reflection. Now the reflection, you can see we talked about this in the last video, where if you have the reflection node wired up, you will get the environment reflections. And you can see we are definitely reflecting the environment in the scene, but you won't see it here because it doesn't load it into the node material editor. It just knows that we have reflection wired up. And so if you load something specifically into color, it'll use that. Otherwise, it uses whatever's in the scene. So just wiring up the reflection node is all we need to do to get our environment light. I'm going to pull this out of the way because I know I'm going to need some extra space down here. And so let's take our roughness and metallic, move those out of the way as well. And let's bring our base color down here. So our base color is right now white. And the most simple operation I can do is let's just change this to the blue color that we want. So I'm going to grab our color and we'll come into the blues here, somewhere around here, and we'll drop in kind of a light, somewhat desaturated blue. Something like that I think is fine. Now, the next thing we have to do is put white into the numbers. So that would be the paint for the numbers. And the easiest way to do that is, let me copy and paste this node, and we'll call this numbers color. And we want this visible in the inspector. And I do this with all of my shaders. I get in the habit of anything that I have that's an input that I know may change, I will expose it in the inspector, because then I can open up the inspector and make changes on the fly or debug. I can grab and code and make my changes there, but it's really nice to be able to have those right in the inspector, and I don't have to open up the node editor to make changes just to a value of a node. So we have our numbers color, and that is exposed, and it is also linear space, which is great. And so I'm just going to choose kind of almost white color. So now the easiest way to say I want blue where we have the plastic of the die and white where we have the paint in the numbers is to use a lerp node. So let me drop down here to Interpolation and grab a lerp node. And so the way the lerp node works is the left channel is anything that is black from our gradient, and the right channel is anything that is white from our gradient, and any gray in between is a mixture of the two. So I know for a fact that our numbers are black for the background and white for the numbers themselves in the mask. So I'm going to grab the red channel and drop it in gradient, and then grab the white color and drop it in the right channel and the blue into the left channel. So now we have our linear space blue, we have our linear space white, and then I'm going to take this lerp output and drop it right into base color. And now you see we have our numbers right there on the die. So that's step one. Great. Let's move these a little bit out of the way and go on to the next part. So the next part is our metallic isn't going to change because both plastic and paint are going to be dielectric. So I'm just going to move that up because we're not going to need it. But you can see here we have kind of a similar reflectivity, glossiness to the paint and the plastic. And I want the paint to be a little less reflective. So we need to change the roughness value. And right now our roughness is set to 0. Let me change that for the whole die right now to like 0.2. Just make it a little less reflective. And so the numbers have to be even less reflective. And so we're just going to do the exact same thing we did just now. So I will copy and paste our roughness, and we'll call this roughness numbers, and visible in the inspector. And then I'm going to grab another lerp node, and same thing over again. Our background, our numbers, and then our mask. And let's make our roughness let's say, well, let me wire it up so we can see the change happen. So our lerp here would just go into roughness, and right now you'll see no change because the roughness for the plastic and roughness for the paint are the same roughness. But if I change this to something like 0.6, now you can see that 10 got much dimmer. It's not reflecting as much glossiness. And so that makes the die feel like there are multiple materials together. And that's kind of what you would normally do in PBR with textures, is to say, when I have a material shift, I want to change either the metallic or the roughness or the color so that I can see that there's a material shift. And when you start changing metallic, obviously you're going to get more reflection of your base color if it's metallic versus not metallic. If you are changing your roughness, you're going to say this is a glossier surface if it's a low roughness, or a more matte surface if it's a high roughness. And so that's a way to kind of make your asset a little bit more believable, more alive. Like I can see that there are many different materials making up this object. So, okay, great. Let me move those out of the way. And we are almost done here. So the last thing we want to add is that iridescent quality to the plastic. So that was that pink sheen on the glancing angles of the die. And so we have a node directly for that. So we come down here to our PBR nodes, and I'm going to grab our Sheen node. And now Sheen has 3 different inputs to it. We have intensity, we have color, and we have roughness. So intensity says how much sheen is applied to the surface here. Color is what color is the sheen that is reflecting on glancing angles, and the roughness is how broad are those reflections. So something that's very low roughness is going to be very sharp on the very edges. Something that's high roughness is going to be very broad and almost cover the entire object. So you'll see that contribution even in faces that are closer to F0, which is right in the center, not on a Fresnel edge, but kind of wrapping the entire object. So you want to make decisions based on what the material should feel like. And so you can either use factors for this, floats for intensity and roughness, or color 3 for the sheen color, or you can use textures as well. So let's say you have a chair that has a fabric seat on it. It's a wooden chair with a fabric seat, and we know that the fabric on the seat has to have a sheen to it. You could actually use a texture for your intensity and run that into the intensity input. And then basically all of the wood would have no sheen, but the fabric would have a sheen because you could create a mask around where you want sheen or where you don't want sheen in your texture sheet. Same thing with roughness. Maybe you want to vary the roughness across fabric so that the sheen feels like it's worn in some areas, or maybe it's velvet and or microfiber, and depending on how the fibers on the surface are laying, it's more has more sheen or less sheen. So you can use a texture in that sense. And the same thing with color. Maybe you've got a couple of different textiles on your chair, and they have different sheen colors. You can pass in a texture that has colors isolated based on the UV of the mesh that you want to have a specific color. So in either case, you can use either a factor or a texture. In this case, we're just going to use factors. However, I do still want to have a separation between the numbers and the plastic. So right now, I'm just going to grab a float for intensity, and we're going to call this Sheen Intensity. And I'll expose it to the inspector. And we're just going to set this to 1. So this is 41, just 1. So this is a full intensity on Sheen. The color is, let me grab this base color, I'll copy and paste that. It'll be a little bit faster. And we're going to call this Sheen Color. Okay. And visible in inspector is great. And we're going to pump that in. And we're going to make sure it stays in linear space. And let's choose kind of a purple pink color here. Yeah, something a little bit lighter like that. Okay, great. So the next part is roughness, and I'm going to set the roughness and visible in inspector. We're going to set the sheen roughness to a value of, let's say 0.5. And then when I wire up Sheen, you'll see we get this pop of color. So we've got this pink color showing up in these glancing angles over here as well in the 7. You can even see a little bit on the 2. And that has to do with the roughness. So if I take the roughness down to, let's say 0.1, all of that pink went away from the face of the 2 and the 7 because it's really only hitting this edge. And so it's going to be very, very glancing just on the edges of the incidental faces. And it depends on what you're doing, but typically you'll probably want a broader sheen reflection. So if I went up to 0.9, you'll see it's really starting to come around and influence the rest of the color of the dye. So I think maybe like a 0.5 is probably about right, where we get a little bit in these edges and a lot on the super glancing edges. So, okay, that is great. But again, remember we talked about how the paint of the numbers is a different material. And right now you can see on the 10, that 10 is pink on the paint because it is also getting a full intensity of the sheen. So one more time, we're going to do our trick of this lerp. And so I'm going to leave the roughness like that and the sheen color like that, because if I change the sheen intensity and turn off the intensity for just the numbers, it does not matter what the roughness is. It will be completely removed. So let me go back up to Interpolation here and grab another lerp node. And then I'm going to copy and paste the sheen intensity, and we'll call this, how about sheen numbers? Great. And we'll change that to 0. And then again, we want left for the dye, right for the numbers, and then the red channel in the gradient. And then I'm going to drop this in intensity. And if you watch the 10, you'll see we dropped out all of the sheen color from that paint in the 10. So basically, that's it. So we've got our 2 colors for the background and for the paint on the numbers. We've got the 2 roughness values for the background and the paint. And we've got the 2 sheen values for the background and the paint. So that's all we need to do. And so if we come in here and we zip around, it is pretty much what we did before. You can see there's a lot of pink showing up in the iridescence of that sheen. We've got two very distinct materials because it's very reflective on the plastic surface, but not reflective at all on the paint on the inside of the numbers. And you can take this, as far as you want with textures and roughness maps and, blending a bunch of things together. And so what we're going to do after this is we're going to do the other two dice. So we have our center and right die, and we're going to do two different techniques on those. We'll do some metallic techniques on the center die. Maybe we'll do some special effects on it or something like that. And then on the right die, we're going to dive into some transparency, some subsurface scattering, transparency, transmission, refraction, so that we can really see what's going on with the die in kind of a glass effect. So over the next few weeks, we'll be adding more videos to this series. So if you want to be informed about when those come up, make sure you subscribe below and hit the bell icon so you can be notified when we upload a new video. If you have any questions, make sure you drop them down in the comments below and we'll get back to them as soon as possible. We hope this is an enjoyable series so far, and that you'll learn some new things along with how to use the PBR nodes, how to use some of the extra PBR next features like clear coat and transmission and Sheen, which we went over today. So if you have any questions, let us know. We hope you enjoyed it, and we will see you next time. Take care.